Good morning, everyone. My name is Ayane Kusafuka from the University of Tokyo. Let's start my presentation. In baseball pitching, accurately controlling a ball to the target position is one of the most important skills. Although many studies have attempted to understand the mechanical and neural mechanisms related to pitch accuracy from different points of view, they are not entirely clear. For example, some previous studies focusing on the relationship between the movement of the body and final pitch location reported like this. It was reported that high and low throws results from inappropriate timing onset of the rotation and to inappropriate timing of ball release, and that pitching from determines probabilistic structure of errors in pitch location. Although the pitch motion is complicated movement achieved by coordinating movements of the entire body, finally, the fingers at the time of ball release is important, and it gives the ball various mechanical characteristics. Ball dynamics is determined. In other words, to know the mechanical characteristics of a ball right after a ball release, which cannot be controlled by human afterwards, can be considered to the same as to know the final pitch location as well as the total ball dynamics. There are many mechanical ball parameters at ball release, which called the release parameters in this study, and various previous studies reported about them. For example, the spin rate, which is the number of the times the ball rotates per unit time, and the spin axis, which is the orientation of the ball rotation, is different from each pitcher and greatly contribute the trajectory of the ball. In addition, compensatory relationship among release point, which is the point at which the ball released, the speed, which is the magnitude of velocity of the ball, and the pitching angle, which is the direction of the velocity, was examined, and it contributed releasing a variability of performance in a ball throwing task. In this way, pitchers control so many factors when throwing balls, but in these studies, only a few parameters are considered. There are variations in each parameter, and the control of all parameters should be necessary to realize accurate pitching. Moreover, a question arises about the weighting, that is, which parameter among them is important for controlling the ball. However, it is not clear the relationship between the release parameters and the ball dynamics, especially the pitch location. Therefore, to understand the underlying mechanisms of pitching accuracy, we should first note the influence of each release parameters on the final pitch location. Meanwhile, focusing on release parameters have advantages like this. With recent advance in science and technology, measurement equipment and data analysis have made remarkable progress. In baseball, for example, TrackMan, which was developed by applying a military ballistic tracking system in 2003, is generally used as data analysis system. It is easily possible to measure not only speed, but also various parameters and the trajectory of the ball with high precision and large quantities. Furthermore, since it is possible to obtain such information in real time, practice and teaching can be aimed at measurable numerical values rather than ambiguous feeling. So, our research question is which parameters should be controlled to achieve accurate pitching? All parameters are involved to pitch location. All parameters are involved to pitch location, but their importance should be different. The purpose of this study is investigate the influence of each parameter on pitch location by creating a simulation. We create a simulation for predicting the pitch location from release parameters. By calculating the pitch location when each parameter is changed individually in the simulation and comparing the magnitude of the fluctuation, it becomes clear which parameter influenced the pitch location to what extent. However, how to determine the range of fluctuation of each parameter? As it is not clear to what range each parameter changes, we examine the values of actual baseball pitching. To obtain the pitching data, 7 pitchers, including former professional baseball pitchers, were asked to pitch fastballs to same-side batters. For example, in case of right-handed pitcher, a right-handed batter, and were instructed to aim at the catcher's mitt, which was low and outside. The total data of 187 pitches were obtained. The release parameters were measured using TrackMan. The range of variation of each parameter was determined based on these measurement results of each pitcher. Next, to create a simulation, it is necessary to consider the mechanical elements acting on the ball at release. The three-dimensional orthogonal coordinate is defined. The origin was taken as the center of the pitcher plate on the mound. The orientation of the x-axis was the direction of the home base. The y-axis was oriented in vertically upward direction, and z-axis was oriented in the third base direction. Based on this coordinate, release parameters are defined. The pitching angle of the ball is given by the elevation angle theta1, theta1, and the azimuth angle theta2 in the polar coordinate system. And the spin axis of the ball is given by the elevation angle theta3 and azimuth angle theta4. Then, an equation of motion is set based on this coordinate axis. Generally, drag and lift are expressed as follows. The equation of motion of the ball coordinate drag and lift can be expressed as follows. The value of the coefficient used in this study is same as in previous study, like this. The pitch location of the ball can be calculated by solving this equation of motion as an initial value problem on differential equation. Using the above, the outline of simulation expressed like this. The release parameters are used as the initial condition, and the pitch location is calculated based on aforementioned equation of motion and the numerical analysis methods. By solving the equation of motion using numerical analysis method, the change in the position of the ball can be calculated at every moment, and the calculation is repeated until the ball reaches the catcher. Summarizing the above, the outline of this study is expressed like this. As the first step of pitching control research, we investigated the possibility of the fluctuation of the pitch location by the range of release parameter in the actual range. By calculating the pitch location when each parameter is changed individually in the simulation, and comparing the fluctuation, it becomes clear which parameter influenced the pitch location. The range of the changing parameter is from minimum value to the maximum value of each pitcher, and the other parameters are fixed to average value of each picture. Furthermore, in addition to simulation based on statistical analysis, the characteristics of release parameters are investigated. By the stepwise multiple regression analysis, the explanatory rate of the pitch location of each parameter is calculated for each picture. Here we have the results. The fluctuation of the vertical pitch location, which is represented by y-axis, when each parameter was changed, is summarized. When the elevation pitching angle was changed, the fluctuation of the vertical pitch location was the largest. The pitch location varied by approximately 30 centimeters each time the elevation pitching angle was changed by 1 degree. Then, when speed, and the release point is changed, fluctuation was large. These results show the similar trend among all pictures. On the other hand, the fluctuation of horizontal pitch location is summarized like this. When the azimuth pitching angle θ2, was changed, the fluctuation of the horizontal pitch location was the largest. The pitch location varied by approximately 30 centimeters each time the azimuth pitching angle changed by 1 degree. Moreover, the fluctuations were on the order of a few centimeters even if the other parameters were changed. These results show a similar trend among all pictures. Here we have a result of multiple regression analysis. The stepwise multiple regression analysis indicated that elevation pitching angle θ1, which is blue, light blue, and the speed, which is blue, and spin axis, which is green, affected the vertical pitch location. Like this. And the horizontal release point affected the horizontal pitch location. The explanatory rate of each parameter was different for each picture. And azimuth pitching angle θ2, which is red, and spin axis, which is green, and the horizontal release point, which is orange, affected the horizontal pitch location. This indicates that there might be different coordinate relationship between parameters for each pictures. Summarize the results. It is suggested that there are 3 types of parameters. Comparing the pitch location when each parameter is changed within the actual range, it was found that pitching angle and speed, which is the red, that is, the velocity vector considerably affected the pitch location of both directions in all pictures. This result was also supported by multiple regression analysis and suggests that adjustment of these parameters is an important skill relating control. On the other hand, in spin axis, which is blue, although the fluctuation was very small in the simulation, the explanatory rate to pitch location was shown in many pictures. This result showed that spin axis had little influence when it was fluctuated alone, but had an explanatory rate by combined with other parameters. Therefore, it was suggested that this parameter changed together change of other parameters. Moreover, the release point, which is green, which trends to be emphasized, conversely caused the fluctuation of the pitch location, but the explanatory rate to pitch location was not shown. This result suggests that the inference of release point was cancelled by change of other parameters and the lost explanatory rate. Thus, release point may have the cooperative relationship with other parameters. So, how to the vertical pitch location be represented by using only the pitching angle and speed, which are common to all pitchers? We extracted only parameters that directly influence the pitch location and investigate how the pitch location is reported for each pitcher as further study. A regression model for predicting the vertical pitch location using the elevation pitching angle and speed was shown by this equation. Moreover, a curved surface that shows the relationship among the elevation pitching angle, speed, and vertical pitch location was similar for each pitcher. By calculating the pitch location obtained by substituting the measured release parameters into this equation, it was found that the error from the simulation result using all parameters was approximately 3.7 centimeters. Also, from this result, it was found that two parameters are common factors affecting the pitch location. From this research, we were able to know about the release parameters which affect the accuracy of pitching. In baseball pitching, the pitching angle and speed are directly influence the pitch location. Since it is difficult to be conscious of many things during actual pitching, extracting important elements may be useful for practice and teaching. Moreover, in addition to similar results for every pitcher, the results of multiple regression analysis were different for each pitcher. This indicates that the elevation pitching angle and speed are common factors to determine pitch location, but in other parameters, such as the spin axis and release point, there are probably different relations with each pitcher. It is clear that the method of realizing the accuracy of throwing does not necessarily improve the reproducibility from the previous studies of underarm throwing and the darts throwing. That is, the strategy is not one. In this study, it was suggested that the same interpretation is possible in more dynamic throwing motion of baseball pitching. In the future, it is necessary to consider the relationship between parameters in more detail and how to adjust them, and the mechanism of pitching accuracy would become more understandable. If you have any questions, let me know later. Thank you very much.